Number 1 is the initial price of a car is $30,000. The value of the car depreciates by 20% per year. If the car is new in 2005, how much will it be worth in 2010? So these are these types of appreciation, depreciation questions. Appreciation means increasing. And depreciation means decreasing. So if I'm appreciating, that means I am going to increase. So I start off with final, and I write these in this order. I go final equals initial, and I'll label these after. And then I'm appreciating. So I do 1 plus my interest rate to the end. And I'll explain why that's the formula. For depreciation, we're going to do final equals initial. That doesn't change. But it's going to be 1 minus I to the end. Try and write a test with that. So F is the final amount. I'm going to play the podcast for him later so you can see how loud his video is through my podcast. I is the initial amount. Then people are like, what's this symbol? That's a 1. It's not a symbol. It's just a 1. And then I is interest rate in decimal form. And N is always number of years. Okay, the reason why we do 1 plus interest rate or 1 minus interest rate is I have interest rate in decimal form here. Does everyone see that? So if I had like 24%, I would divide that by 100 and I'd get 0.24. We agree? So this 1 is actually decimal form for what percent? 100. If I have 100% of something, am I increasing or decreasing? Trick question. If I have 100%. It's the same. I'm neither increasing nor decreasing. I have 100%. So say I had 7 fish. I have 100% of 7. I have 7 fish, right? If I go above 100, I'm increasing, correct? If I go below 100, I'm decreasing. We agree? So that's why we do 1 plus interest rate and 1 minus, because this is 1 is 100 in decimal form, and then I'm going to add the interest rate in decimal form. Or if I'm decreasing, I take 100 in decimal form, which is 1, minus the percent, correct? So let's talk about this question. It says, that's so much quieter, brings great joy to my heart. Okay, the initial price of the car is $30,000. The value of the car depreciates by 20%. So is it increasing by 20 or decreasing? Decreasing. Yeah. If the car is new in 2005, how much will it be worth in 2010? So it wants how much it'll be worth in 2010. So let's write down what we do know. So we have knowns and unknowns just like you do in physics or whatever. So I know I need Fi, little I, N. I can only be missing one of them, correct? Whenever you're using a formula, you can be missing one variable in order to solve for the other ones. So the initial price is $30,000. What do I have? I have capital I, which is the initial amount. So I have capital I, which is 30,000. It depreciates by 20% per year. What's that? Little I. Little I is what? 0.20. If you don't remember how to turn it into a decimal, to get rid of the percent symbol, you divide by 100. Then, if the car is new in 2005, how much will it be worth in 2010? How many years is that? 5. What's that letter? N. So, and then only thing I've left is the final amount. Is that actually what it's asking me to find? How much is it worth in 2010? Is that the final amount? Yeah. So that's good. That's what I'm looking for. So let's fill it into our formula. It's the depreciating formula. So I have F equals capital I 1 minus interest rate to the N. So my final is what I'm finding equals 30,000 bracket 1 minus 0.20 to the 5. So I get F equals what? Now let's look at this for 1 second. This is 30,000 0.80 to the 5. So is this value less than 1? Yeah, if that value in your bracket is less than 1, it's decreasing. And then it's decreasing by how far away it is from 1. So how much is this one decreasing? 20%, 0.2, right? Away from 1. So that's why this makes sense that it's at 0.8, right? That's what I have left. I have 80% left every year. 80%, 80%, 80%. Do I have to do any math to this? No. I can type it in my calculator. Everyone type it in and see if you get the same answer as me. $9,830.4. So in 5 years, that's the final amount. Am I done? It's a word problem. No? So here it says, reiterate what it asks. How much will it be worth in 2010? What is it? The car. So the car will be worth $9,830.40 in 2010. Then I'm done. We agree? We always reiterate what we found. And reiterate means restate what we found. And these are the sentences that I was really good at because you're just literally restating the question. Not the greatest at English, but this I can rock at. Just restating the question. Okay? Then B says, how long will it take to the nearest tenth of a year, so that's 1 decimal place, for the car to be worth half of its original value. So what did we get now? So let's go through. We have F, we have I, we have little I, we have N, we need to have 3 and 4. So, did the initial price change? No. Still worth 30,000. Did the depreciation value change? Little I is still 0.20. It's asking me for how long it will take. So that's N, right? I should be missing N because it says how long. What's the final? Well, how'd you get that? That's right. How'd you get that? It says it's worth half the original. The original is 30,000. Half of that is 15,000. So this is A. So B, my final is 15,000. They should be the same units, final and initial, so they're dollars. 30,000. Little I is 0.20, and N is what we're finding. So let's fill it in. Final, 15,000 equals initial, 30,000. Bracket 1 minus 0.20 to the N. I don't know the exponent. When I don't know the exponent, I have to convert to a what? A log. We have to convert to a log. I'm going to have 1 2, 3, 4 pieces of information. So what am I always going to have to do first before I convert? Divide over that initial every single time. That's a highlighter, but okay. Divide by 30,000. And I get 1/2 equals 0.80 to the n. So this is why solving by conversion, by solving to a log and solving an exponential is very important, because we can get the word problem set up, but if we don't know the variable, we have to actually solve it algebraically. Some people are like, I can guess and check. No. If it says algebraically, you cannot, which is all written response. So I need to convert this. So I always go to my base first. What's the base? 0.80, correct? And how do I know I need to convert to a log? Because look, the variable's in the exponent, and the only way I can bring that down is by common base or conversion. Most people will just convert to a log. So I'm going to get log base what? 0.80, yeah. So this goes as my subscript. And then 1/2 is actually the same height as the log. Do you see how I have the same height? Now, I'm going to go log base 0.80. What's friends doesn't stay friends, right? So I'm going to get 1/2 here, and it's going to equal n. Now, everyone plug it in the way you know how. So you can use the log base button if you have it. If you don't have the log base button, you can go log 1/2 divided by log 0.80, right? That base has to go on the bottom. So every single person is typing it in, because the saddest thing is if you can do this, but you can't get the right answer when you type it into your calculator. Now, that's a lovely answer, but it asks us to get it into what? The nearest tenth, which we wrote down as 1 decimal place. So n equals 3.1. So it will take the car 3.1 years to what? To be half of its original value. So always write the whole thing out. The saddest thing is if your sentence sucks and they take off marks. Okay, we don't want that. Yeah. Okay, this one's increasing, so what's the only difference? 1 plus. So I want you to try 2 and 3. Try them out. So number 2 says, in 2002, the population was 160,000. Now you have to watch yourself and see if that's the final or the initial, so you have to keep reading. It's increasing, so I'm going to go 1 plus at 4.5%. Now remember I told you divide by 100, so that's 0.045, right? They want the population in 2005. So was this the initial or the final, this 160?
Initial.
Initial, because it was earlier year, right? So what are we given? We're given the initial is 160,000. Final, we're looking for the final population. Interest rate is 0.045. It's increasing, so I know I'm going to have to add. And it wants in 2005. How many years is that? 3. So, we do final, which is F equals 160,000. Bracket 1 plus 0.045 to the 3. That can pick up all of what you guys are saying. So we get 182,586 people. Because, can we round up and find a partial person? No.
No. You totally don't round up.
Okay.
You totally.
All right. So, the final population, so the population in 2005. Was 182,586. All right. Then we have to do B. B says if the population continues to grow at this rate, so no different rate, determines the number of years, girls and boys, to the nearest year for the population to double. Then double what it was in 2002. So the 2002 is what threw people off. Okay, it's doubling what was happened in 2002. So my initial is still 160,000. My final is double that, so 320,000. And it wants N. So it's going to be 320,000 equals 160,000, 1.045 to the N. So I have to convert. So I get 2 equals 1.045 to the N. Now you only convert to a log if you don't know the exponent. Are we missing the exponent? Is that where the variable is? Yes, then we convert to a log. That's the only time. So we get log base 1.045 of 2 equals N. So N equals 15.74730,184. And the question says to the nearest year. So N equals 16 years. And it says if the population grows, determine the number of years to the nearest year for the population to double. So it takes 16 years for the population to double. All right. Then we have 3. It says if the population of the city was 250,000 on January 1st, 2000, and 310,000 on January 1st, 2008, how many years is that? Which is the initial? 250,000. What's the final? 310,000. If the growth rate of the city can be modeled by an exponential growth function, the average annual growth rate of the population to the nearest tenth. So we're looking for I, correct? So we have final equals 310,000. Initial equals 250,000. I is what we're finding. N is 8. So now we have 310,000 equals 250,000. Bracket 1 plus I to the N. Is the exponent where the variable is? No. If the exponent doesn't have the variable, I'm not converting to a log. I can just solve it like normal. The only reason why we had to learn logs is when we had a variable in the exponent, which I do not have a variable in the exponent. I have an 8. So we're going to solve it like normal math. So the first thing we're going to have to do is divide that 250,000 over. So I get 1.24 equals 1 plus I to the 8. So people want to convert it. Would converting help? No, you're going to get a 1 plus I in the base of a log, which I don't know how to do that. So what do you have to do? Math. So how do I get rid of an 8? I 8 through. So you go 8, math. You don't know how to do it. You go 8, math, number 5, because that's where you're putting it in. 1.24. And I get 1.027253692 equals 1 plus I. And how do I get I by itself? Subtract 1. So I get 0.027253692. And they want, it says here, to the nearest tenth of a percent. Is that in percent? No, so what are we going to have to do? Multiply it by 100. And so I get 2.7%. And I'm not done because I have to write a statement. So it says the average annual growth rate of the population of the city. So 2.7% is the average annual growth rate. Of the population of the city. Okay, then we're going to flip over. We're going to look at half-life doubling and tripling. So half-life doubling and tripling would still follow the same scenario. We would have F equals I. Now, normally we had a 1 there, correct? And we went 1 plus the interest rate, or 1 minus the interest rate, and 1 represented 100% in decimal form, correct? Now we're going to do, technically, 1 times the rate for the end. Do I need a 1 if I'm just multiplying something by 1? No, I'm proving a point. So the formula will actually just be F equals I R to the n. Because 1 times the rate just becomes R. We agree? So if I said something was doubling, it would go from 100% to what? 200%. And what is that in decimal form? A 2. If something was tripling, it would go from 100% to 300%, which means it would be a 3. And if something was halving, it would go from 100% to 50%, which is 0.5. We agree? So you still are going from 100% to something. So here it says, a lab tech placed a bacterial cell. So what's my initial? 1. Into a vial at 5 a.m. Cool. The cell divides in such a way that the number of cells, and I'll show you why this doesn't just stay as an n. The number of cells doubles. It doubles. So what's my R going to be? 2, because now it would be 200% technically. Okay? It doubles every 4 minutes. Now I want to show you, this formula actually doesn't have just an n, because our n is time versus period. So it's going to be t, well that is a highlighter. So it's going to be T over P. Now, if you can figure out the T and the P, you're in a much better boat than most people. So, T is time to reach final. And P is the period. So the period is how long it takes to double, triple, half, etc. So this one says that it doubles every 4 minutes. So every 4 minutes it's doubling and doubling and doubling and doubling. Doubling and doubling and doubling. So what would that be? P or T? P, because that would be the period. The giveaway if it's T or P is if it comes after the word doubling, tripling, or halfway. So if this doubles every 4 minutes, that means that's the period that it doubles. So in 4 minutes, I'm going to have double what I had before. In 4 minutes, I'm going to have another double what I had then. 4 minutes, I'm going to have double that. 4 minutes, I'm going to have double that. 4 minutes, I'm going to have double that. So it's going to grow quite quickly, right? So if I had 1 bacteria cell, in 4 minutes I'd have 2. In 4 minutes I'm going to have 4. In 4 minutes I'm going to have 8, then 16, then 32, then 64, then 128. Like it's growing, it's doubling every single time. It's growing exponentially. So if it doubles every 4 minutes, that's my P. Now how long does it take to produce 4096? What's this? Final. And now it's asking you how long does it take to get to final, isn't it? It's saying how long does it take to get to 4096. So it's asking you for how long to final, correct? So what am I missing? The little t. Time to reach final. So we're going to come down here and solve it. So, or go to the next page. Number 1, I have I equals 1. I have final equals 4096, because it's just cells. My rate is 2, because it's doubling. If it's tripling, my rate can be 3. If it's halving, my rate can be a half or 0.5. Okay? Because it's how much of 100% it is. And then it wants, P is 4 minutes, and T is, I don't know, but I know that it's in minutes, because P and T have to be in the same units. Okay? So let's fill in what we know. The formula is F equals I rate to the T over P. What is F? 4096 equals I, which is 1, rate, which is 2, to the T over P, T over 4. So once again, my variable's in the exponent, so I know I'm going to have to convert to a log, right? That's a non-option. But I have 4 pieces of information. I have a 4096, a 1, a 2, and a T over 4. So what am I going to have to do? Divide over the 1. Does dividing by 1 do anything? No. So I get 4096 equals 2 to the T over 4. Now I have 3 pieces of information, right? So I can convert it to a log. So I get log base what? 2. Base my x1 becomes base my log. What goes beside it? 4096, because what's friends doesn't stay friends. And it's going to equal the exponent, which is T over 4. And I write it like this, not with the slash, because people can often do math better if there's no slash, if it's over top of each other. Because right now I'm dividing by 4. How do I get rid of a division of 4? Multiply by 4. So it's a lot more obvious if it's written like this. Let me type that in. So I get T equals 48 somethings. What's the somethings? What's the units? It has to be minutes because P was in minutes, correct? So it says how long does it take for the cells to divide to produce 4096 cells? It takes 48 minutes. For the cells to divide. To produce 4096 cells. Now guys, if your answer, your statement is it takes 48 minutes, cool. 48 minutes to do what? If you put it takes 48 minutes and put a period, you're not getting the full answer. It takes 48 minutes to shower. It takes 48 minutes to wash your car. It takes 48 minutes to run up the stairs. What's this 48 minutes? What takes 48 minutes? Do you know what I mean? So if I can ask you, it takes 48 minutes, what is it? You could say it takes 48 minutes for the cells to divide to produce 4,096 cells, right? You're saying there's cells dividing, and they're going to produce 4,096 cells. So you're explaining yourself. All right. This one, a radioactive isotope has a half-life. What does that give me? That's supposed to be a highlight. Just cross it out. Half-life. What is that? F-I-R-T over P? It's a half-life. It's R. R is either 2 or 3 or a half. This is if it doubles. This is if it triples. This is if it's half-life. So I could use a half or I could use 0.5, yeah. So our R is a half, or we could say 0.5. It's the same thing. Don't know why I put it in brackets, but you're welcome. It has a half-life of 7 years. Follows right after the word half-life. So it has a half-life of 7 years. So this year, it's whatever it is. In 7 years, it's half of that. 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 So is that T, time to reach final, or is that P, the period, how long it takes to half? It's the period. It's how long it takes to half. It halves every 7 years. 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 So that's the period. That's how long it takes to half. Determine how much of the isotope must be initially present. So what's it asking me to find? How much must be initially present? What's it asking me for? I. To decay to 60 grams. So that's final. In 14 years, that should be plural. What's that?
RT.
RT. Time to reach final. 60 grams in 14 years. I'm going to rewrite those on the next page. So I have R equals a half, or 0.5. P equals 7. I equals question mark. F equals 60. And T equals 14. So let's fill in our formula. Final equals initial. 0.5 to the T over P. 14 over 7. Is my variable in the exponent? Is my variable in the exponent? If we look in the exponent, is there a letter? There we go. No, there is not. So do I have to convert to a log?
No.
No. It's math. It's math. Yeah. Yeah. So at this point, I'm just mathing, correct? I only have to convert it to a log if the variable's in the exponent or the letter's up here, which it's not. So I go 60 equals I. What's 14 divided by 7? 2. So I have 0.5 squared being multiplied by I. How do I move it over? Nope. I have 0.5 being multiplied by I. Divided. Perfect. So I equals what? $240 something. Graham, someone whispered it. You were correct. The whisper answer was correct. So here it says, determine how much of the isotope must be initially present to decay to 60 grams in 14 years. There must be 240 grams of isotope initially present. And if you want to be even more thorough, you keep going. Initially present to decay to 60 grams in 14 years. Okay, so for 3 and 4 and 5, I don't want you to actually solve anything. I just want you to write down what the variables are. Okay, you try your best, just write down what the variables are. And there should be one variable missing. Okay, so 3, 4, and 5, write down your variables. Okay, so number 3 says the half-life. So that's my R. So what is the half-life? So that's my R. What is the half-life of plutonium-232, which is a lovely little isotope, but nowhere to be found anywhere? If in 204 minutes a sample decayed to 164 of its original. So is 204 time to reach final or the half-life time? Time to reach final, because it says what is the half-life? So it's asking you for P. What is the half-life if in 204 minutes it took a sample to decay 1/64 of its original? So the key on these ones is you get to pick the initial. So if I always pick the initial to be 1, and then the final is 1/64 of 1. What's 1/64 of 1? 1/64. If I pick 100, I have to times it by 1 over 64. If I pick 2, I would have times it by 1 over 64 and write that one down. So the easiest one to do if I don't have that is 1/64 the original. I can make the original be whatever I want. The final just needs to be 1/64 of it. Right, Alec? Yeah. So let's fill in our formula. 1 over 64 equals initial, which is 1, rate, which is a half, to the T 204 over P. Now I know that my variable's in the exponent, so at some point I'm going to have to convert to a log. Correct? Variable and exponent convert to log. So you have to do every single time. So do I have a letter in my exponent? Yes, I'm going to have to convert to a log somehow. And what I always have to do is divide my initial over first. Dividing by 1 does nothing, but I'm doing it to prove a point. So I get 1 over 64 equals a half, or if you so choose, 0.5, sorry, 204 over P. So I have 3 pieces of information. Can I convert to a log now? Yes. So I get log base what? Log base 0.5, so this is a subscript. What goes beside it at the same height as the log? 1 over 64, and it equals 204 over P. Now some people say, well, I just multiply by 204. Is that true? No, I'm going to have to multiply by P, correct? So I multiply by P, so I get the P up here. And then how do I get P by itself now? So now I have P times log 0.5, 1 over 64 equals 204. Now what can I do? It's P times. So how do I get P by itself? Divide by this big old log. Log 0.5, 1 over 64. So everyone's typing it in to see if you get the same answer as me. If you're someone who has the old calculators, you're going to have to do log 1 over 64 divided by log 0.5, enter, and then go 204 divided by that. So it's just 204 divided by second answer. So everyone's trying it on their calculators. You need to make sure you can do it with yours. And I get 34. 34 what? 34 what? It says T and P have to be in the same unit. And then says, what is the half-life of plutonium-232? The half-life of plutonium-232 is 34 minutes. What does that even mean? The half-life of plutonium-232 is 34 minutes. What does that even mean? What's happening every 34 minutes?
Decay.
It's decaying by half. In 34 minutes, I have half of what I had before. The next 34 minutes, I have half of that. The next 34 minutes, I have half of that. It's just halving every 34 minutes. Okay? We'll do here. Oh, this will be the last one we'll do today. So material has an initial mass of 50 milligrams. And a half-life, so R equals a half, or 0.5. A half-life of 20 minutes. Is that P or T? Half-life of 20 minutes.
P.
P. It halves every 20 minutes. Half-life of 20 minutes. Every 20 minutes I'm halving. So that's my P. Find the mass after 35 minutes. So T equals 35 minutes, and they're making me find what? What are they making me find? Final. So I have final equals 50 bracket 0.5 to the T over P, so 35 over 20. Do you think they'll have the oopsie of 20 over 35 on your test if you mess them up, put them in the wrong spot? They will. Now, is the variable in the exponent? No. So I don't have to convert it to a log, and it's all on this side, so I just need to type it into my calculator. And final equals 14.8650, blah, 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 blah. And they want, find the mass after 35 minutes, didn't give a rounding, so I'm just going to go to whole. So I'm going to go 15 milligrams. I would say the mass after 35 minutes is 15 milligrams.